Okay, so we found the initial allocation and the final allocation using Hamilton's method in the previous video. I'll post a link somewhere. In this video, though, we're going to find the other guy's method. His name is Lowndes. I don't know how to pronounce it. L-O-W-N-D-E-S, I think. Anyway, so he does the natural quota and the initial allocation the exact same way as Hamilton does, but his final allocation obviously won't be Hamilton's final allocation. It'll be Lowndes' or whatever his name is final allocation. So the first thing we're going to do is we're going to make the decimals column that we made in the previous video for Hamilton's method. We're going to make it a little bit more accurate. And the way that we do that is by copying over more of the decimals. So over here we already have 0.71, and we're going to just add a few more. So we're going to make it 0.71428, and over here we have 0.54. We're just going to add a 0.81. I'm just copying the numbers from the natural quota column. Here we have 0.94, and let's add an 897. Here we have 0.64. Let's add a 2857. 2857. Here we have 0.15. Let's add a 306. Okay, so the big difference between Hamilton's method and Lowndes', I don't know how to pronounce his name, I'll just call him Lowe's, is that he uses what's called a fractional part. So the fractional part is defined as the decimal divided by the initial allocation. So the decimal over here is 0.71 and the initial allocation is 4. So let's just do 0.71 divided by 4. We get a fractional part of 0.17, and let's do this for each of them. So here we have the decimal divided by the initial allocation. Here we have the decimal divided by the initial allocation, and the decimal divided by the initial allocation. Feel free to pause the video and do these by yourself if you want to practice putting them into your calculator and doing the division. I don't really care. Okay, so whereas for Hamilton's method, let's unhide these. Where did you go? For Hamilton's method, we took the largest of the decimals, the 0.94, the 0.64, and the 0.71, and we added 1 to the initial allocation. In this case, we're going to take the largest fractional parts and add 1 to those initial allocations. So this is from L-O-W-N-D-E-S. Okay. So the way that he does it, I'm just going to make this smaller. Okay, so we can see everything. Okay, so here the largest is obviously 0.31. So let's move this one from 3 to 4. Then the next largest is 0.27, so let's move this one from 2 to 3, right? And then the next one looks like 0.17. It's bigger than 0.10, and it's bigger than 0.05. So let's move it from 4 to 5. And copy over the rest. So here we have 6, here we have 3. So if we add these up, let's add 3 plus 6 plus 4 plus 3 plus 5. We get 21, and that makes sense because that's the total number. Oops, that's the total number of things to be allocated or trucks to be allocated from the fire chief or whoever. So I hope this was helpful. Obviously, if you have any questions, post them below, and I'll post the other guys' methods a little bit later.